Hello, Algebra 2! Hope you guys are having a great day. Today we're going to learn a different method of factoring. So, just so you know, right, factoring is like getting a function to a point where you have only factors, right, things multiplied by each other that make up the entire function. So, like, if you have x minus 1 times x plus 2 times x minus 3 and then a plus 2 on the outside, that's not completely factored, right? Because you can't have that plus 2 out there. That's a problem. That's not factored. Okay, so in order to get factored form, you need something like this. And there's a lot of different ways you can factor, right? If it's a quadratic, there's different methods, and if it's a difference or a sum of two cubes, there's a different way of factoring. If it's a difference of two perfect squares, there's a neat way to factor that. And so grouping is just another method. It's not going to work for every single function, but it'll work for some. And so it's just another tool in your toolbox. Okay, I'm not going to say that it's going to work for everything, but here we go. Step number 1, you want to group terms. You want to group binomials. Okay, so in order to group this, you want to be careful with negatives, right? So I'm going to group the first two terms, okay, because that's fine, but the next two terms both have negatives. So if I end up grouping it like this, I've effectively changed the function, because now I'm supposed to distribute that negative, so it would be a minus 4x plus 12. So in order to keep that 12 the same parity, or the positive or negative, right, you either need to switch the sign, or what I prefer to do is I pull out the negative, so I end up with a plus negative, and then on the inside I've got my 4x plus 12. Okay, and then you can change that plus and negative to just a minus. Okay, so anyways, group the terms. Okay, next step is factor out common monomials, so within the group. Okay, so in this monomial, both terms have an x squared, so I want to pull out an x squared. And here, both terms are divisible by 4, so I could factor out a 4. So I'm going to do that for both of those. When I pull out the x squared from here, I'm left with x plus 3 on the inside. And then when I pull out a 4 from both of these terms, I'm left with an x and a 3, x plus 3 there. And notice now I have, in both terms, I have an x plus 3. So now, because both of those two terms have an x plus 3, I can pull out the x plus 3, or factor out the x plus 3. So when I pull out an x plus 3 from the first term, right, I'm taking out an x plus 3, okay, and then what I'm left with on the inside is that x squared and that minus 4. Okay, so now I have x plus 3 times x squared minus 4. And now if you can factor anything else, namely like this thing here, if I could factor that, or if I could factor that, then you keep going. So in this case, x squared minus 4, that's a difference of two perfect squares. So that actually factors to x plus 2 and x minus 2. So my actual full factored form is the following. So then my final factored form is x plus 3 times x plus 2 times x minus 2. And that equals my original function. It's just in factored form instead of standard form. All right, we got two examples here. I recommend trying it on your own first, and then checking the solutions. All right, this one I'm going to group my first two terms and then my last two terms, but remember, since I'm pulling that negative out, that becomes a minus 18 on the inside. Okay, and then from my first one, I can pull out an x squared. So I have x squared, and then what I'm left with is an x minus 2. And then from the second one, I can pull out a 9. So I'm going to have a minus 9, and then on the inside is an x minus 2. And then both terms have x minus 2 and x minus 2. So I pull those out front, so I have x minus 2, and then I'm left with that x squared minus 9. Done yet? Because x squared minus 9, that factors 2. So that's, again, a difference of two perfect squares. And so that factors to x minus 3 and x plus 3. So your final answer should be x minus 2 times x plus 3 times x minus 3. Bam, factored form. Second problem, same kind of situation. Group the first, group the second. Oh, there's a plus sign in there, so I don't even need to worry about negatives. It's kind of even easier. Both terms here have an x squared, so I'm going to pull out x squared, and I'm left with a 2x plus 1. And both of these terms are divisible by 4, so I'm going to pull out a 4, and I'm left with 2x plus 1, right? Because 4 divided by 4 is 1. Don't forget about that. It doesn't disappear. Okay. Then both terms have 2x plus 1, 2x plus 1. You can pull that out, and I've got 2x plus 1 times x squared plus 4. Now, the question is this done? Okay. Can you factor 2x plus 1 anymore? No. Can you factor x squared plus 4? Good question. Okay, it's not a difference of two perfect squares. So this is actually not going to factor, mainly because the zeros of it are imaginary. So you can just leave it as is, x squared plus 4 times 2x plus 1, and then that is your answer for factored form. All right, last thing. So factor theorem, so we already talked about this in class, but I just wanted to throw that out there again and officially, because we briefly talked about it in class, but we need to actually have it down. So the factor theorem basically says that we know that a polynomial x minus c is a factor of another polynomial if you can plug in c and get 0, right? And that comes from the remainder theorem, because if you plug in c, the answer is your remainder. And so if your remainder is 0, then you know it goes in evenly and therefore is a factor. Okay. Whew. Okay, this is really nice because basically if you find out that x minus c is a factor of another polynomial and you're trying to get that polynomial into factored form, you can divide it out or factor it out so that you can start writing that function into factored form. So I'm going to show you an example of what I mean by this. So let f of x equal x cubed minus 7x plus 6. We need to determine whether x minus 1, x plus 1, x minus 2, and x plus 3 are factors of f of x. And then it says write f of x in completely factored form. So let's see here. Let's check it, right? So in my first case here, x minus 1, c is positive 1. Right? So I plug 1 in. So I want to know what f of 1 is. Well, it's 1 cubed minus 7 times 1 plus 6. So that's a negative 6 plus 6. That equals 0. So I do know x minus 1 is a factor. Let's check the other ones. So for the second one, c is negative 1. Third one, c is 2. And fourth one, c is negative 3. So just go ahead, check those, see if there's any other factors. So it turns out 1, 2, and negative 3 are all factors. Or x minus 1, x minus 1, x minus 2, and x plus 3 are all factors. Okay, the only one that's not is that x plus 1. So these are my factors. Okay. And so what I mean by writing it out in completely factored form is that, okay, let's look at a simpler problem for a second. If I take the number 6 and I say oh, I know 3 is a factor of 6. Well, I can do 6 divided by 3 and get the answer of 2. And I can say, all right, well, I can just rewrite 6 as 3 times 2, right? Because I pulled out the 3 and I was left with 2, right? It's basically just another way to write 6. So it's the same way with polynomials, right? If we start out with a polynomial f of x, and we know that x minus 2 is a factor, and we do division, and we take that function, whatever it is, and we divide it by x minus 2, and then we get some answer. Let's pretend we got x squared plus 3x plus 1. You know now that you can write f of x as x squared plus 3x plus 1 times x minus 2. Okay, so in this case, I'm going to actually just show you kind of one step of this real quick. But we started with f of x, which is x cubed minus 7x plus 6, right? And I want to divide out the first factor. So let's do f of x divided by x minus 1. Okay, and you can use synthetic division or long division, whatever you choose. I prefer synthetic division for this because it's x minus c. So I'm going to do my coefficients, 1, 0, negative 7, and 6. And my c is out there. Add down, multiply, add down, multiply, add down, multiply, and add down, and you get 0. Okay, so what this means is that I can rewrite f of x as x minus 1 times whatever my answer was, whatever my quotient was. And I started with x cubed, so it should be x squared plus 1x minus 6. Okay, then, I mean, I already know the rest of the factors because I checked them up here, but if I didn't give them to you, then you could take this thing and say, oh, hey, that factors. So now I've got this x minus 1, and let's see, what multiplies to negative 6 but adds to 1, right? What multiplies to negative 6 but adds to 1? Well, how about 3 and negative 2? So this ends up being x plus 3 times x minus 2. Now we have that entire function f of x in its completely factored form, right? So that's really nice when you're trying to find zeros and what the function looks like on a graph and all sorts of fun things. Oh, this, yeah, x-intercepts. It's all sorts of good things. So, anyways, good deal. All right, peace out.